Hello and welcome to YellowMan Physics. In this one I just want to talk very quickly about some uses of radiation. So, three types of radiation. You've got alpha, beta, gamma. Alpha is your helium nucleus, so let's just go to alpha, strongly ionising, quite big. Beta is an electron, and gamma is just an electromagnetic wave. Now, this one is strongly ionising, this one is moderately or less ionising than that one, and this is the least ionising. In terms of dangerous, this one is very dangerous because it's so ionising, but it can't travel very far. This one is less dangerous, can travel further, not as ionising, and this one is the least dangerous in terms of it can travel the furthest and it's the least ionising of them all. So, in terms of uses of radiation, they want you to be able to link its properties, how ionising it is, or what will stop it, to its use. So, if you imagine a person and we want to examine some part of them, okay, and we injected them with something that was absorbed by, say, their brain. If YellowMan has a brain in there somewhere, let's do that. We want to look at inside his brain. Oh, sorry, YellowMan. Now, if I inject him with something that's absorbed in his brain that's an alpha emitter, partly this is going to be very bad for YellowMan because alpha is highly ionising and is going to be stopped by anything it comes into contact with. So the alpha emitter will be trapped within his body. It will be damaging the cells inside his body, and the alpha particles won't be able to get out of his skull because alpha is stopped by a few centimetres of air or just paper. So even YellowMan's thin skull will stop the alpha emitters getting out. So alpha is a no-go. Beta, less ionising than alpha, so not quite so damaging to YellowMan. Beta emitter possibly we could pick up a little bit outside of his body, probably around the softer areas of YellowMan. I know he's mostly soft, but let's pretend he's got a skull. Beta is going to struggle to get through the bone, so beta probably out as well. Our favourite go-to is going to be gamma. Gamma is going to pass straight through his brain, straight through the skull, no problem at all. It's stopped by lead or concrete. So if I inject YellowMan with something that's a gamma emitter, and that chemical is absorbed by his brain, it's going to be emitting gamma radiation out, and I can study that. So if we're looking inside people, gamma is quite useful. Not stopped by bone, not stopped by the skin either, and easily gets out. Gamma can also be used in reverse in terms of the treatment of some things, where we can actually direct gamma into people's bodies, and it can be used and focused to kill cancerous cells and things like that. So gamma can be used in reverse as well. Next use, so we've talked about gamma in terms of looking inside YellowMan's head, inside a body, inside a skull. Let's go to alpha. So alpha tends to be used in smoke detectors. So if I put an alpha source here, this is my alpha source, it's emitting alpha particles this way. And then on this side, effectively what I've got is a detector. Now, the mechanism behind this, it's actually completing the circuit because the alpha particles are carrying a charge. But let's just call it a detector. And this is all inside my smoke alarm, which is going to be horrifically badly drawn. This is my smoke alarm. Now the smoke comes up, enters the smoke alarm, and the smoke particles get in the way of the alpha particles. Okay, so the smoke actually gets in the way, and because alpha is stopped by a few centimetres of air, smoke in that air is going to make the air even harder for the alpha particles to get through. So the alpha particles will be stopped, and that will trigger the alarm to go off. So a smoke alarm is really badly drawn. Smoke alarm will cause. So three types of radiation. You've got alpha, beta, gamma. Alpha is your helium nucleus. So let's just go to alpha, strongly. So the detector will be connected to the siren or whatever, and that will cause it to go off. So that is alpha. And last but not least is beta. Now I have to be careful that this doesn't end up looking like something rude. Beta is used quite often to control the thickness of metals. So one way of making metal is that you get a thick sheet of metal and you squeeze it between two rollers. Oh god, this isn't going to end well, is it? Let's carry it this way. You squeeze it between two rollers and then out the other side comes a thinner sheet of metal. Okay. Now above here you're going to have your beta source underneath, so the beta particles are coming out of here, and underneath you're going to have your detector, and this detector is going to feed back into some mechanism that controls the separation of these plates. So if more beta particles get through, it can mean that the sheet's getting too thin and that these need to be moved apart. If less beta particles are getting through, it can mean that this sheet is getting too thick, and these rollers need to be squeezed together so that the metal coming in gets thinner. And that can be a use of beta. Alright, thanks for watching.